Hello. Let's see the connections between two-dimensional arrays and pointers. So we earlier saw that the correspondence between one-dimensional array and pointers. So now we will see the correspondence between two-dimensional arrays and pointers to pointers. First, let's see how a two-dimensional array is and how its memory is going to be. So I'm going to declare a two-dimensional array of integers. In text 10, 20. So what happens? How much size is allocated for this? So this requires 10 into 20 number of integers, right? So that comes out to 200 integers. So the machine is going to allocate space for 200 integers. These many integers are allocated. And what will be the memory address? This, let's say the starting point is of address . So the first address is 1001. All the rest of the integers are allocated space consecutively. So this memory is allocated as a block. What is the zeroth index of this array? The zeroth index of this array, let's say, contains the value 10. We can write this value 10 into that location by the following statement. Right? What about the first location? It will be what about the 20th location here? So in this memory, the memory starts from the 0th location, and what about the 20th location? What should come there? So according to how we see it right now is that the first row of this two-dimensional matrix will be the first 20 values. We saw here that 0, 0, right? The 0th entry of the 0th row is 10, that comes here. The first entry of 0th row comes here, 20, etc. And so the first 20 elements will lie in the first 20 positions. Okay. So index number 20, which is basically the 21st number, if you want to access that, that will be x of 1, 0. And how do you get that? That is 1 into 20. Okay, because each row is of length 20. Therefore, to get the 20th entry, you find out, multiply it by the row number, and that's 1 into 20, and you will get the 20th entry of this array, of this one-dimensional memory view. Now, if I had if I wrote this, where is this memory going to be there? So it will be 1 into 20 plus 2. Right? So we are interested in the 22nd location. Okay, this will be 1 into 20, this will be 1 into 20 plus 1, and this will be 1 into 20 plus 2. That's how you get that location. Okay, so the row number into the column width plus the column number should give me the location in the memory. So is that clear? Right. So this is so what we have here is a two-dimensional view for the programmer. The programmer can now view this array as a two-dimensional matrix. Indeed, it's a two-dimensional array, right? And on the other hand, the memory is is an one-dimensional memory. So our machine will convert this two-dimensional view of the programmer into the one-dimensional machine's view and access the location correctly. Right? This is clear. Okay. Now, so this is also because this is a static. This memory is allocated statically, right? We know that arrays are going to be allocated statically. The memory locations, the memory required for an array is allocated statically. And therefore, since it is allocated statically, the machine can deal with all these things. Now comes a question of what if I want to allocate memory dynamically, right? How can I do this, the entire thing? How can I allocate this dynamically? A two-dimensional array, how can I allocate memory for a two-dimensional array dynamically? Okay, so that's going to be a little tricky. Next, we are going to see an array of pointers. Let me define that first. We have now declared an array of pointers. So when I do this, what is statically allocated right now? So statically, you will be allocated 10 memory locations for storing pointers of type int star. Okay. Now, these obviously this array size 10 is known statically, right? At the beginning of the program knows this fact, and therefore the machine can allocate 10 contiguous block for this for these 10 pointers. This is clear. Next, so what is it we want? We want a two-dimensional array of size this, right? 10, 20. So we have now an array of size 10. What is a pointer array of size 10? Now each of this location we are going to make it point to an array of size 20. Okay, so it will be like something like this. So clear? So let me give some memory addresses. So let's say this is starting memory address is 2000. So therefore this here it's 2000, and this let's say is okay. And this array might be at the location, let's say 10. Okay. Right. So each of these 10 locations are now pointing to an array of size 10. All these arrays have to be allocated dynamically using malloc. That is, we should have written the following code for each of this location. Let me write that. We should have written we should have allocated 20, an array of size 20, an integer array of size 20, and given that address location should be put into each of these array entries. So 0 is now, P of 0 contains the address given by this memory alloc function. Okay. So similarly we have to do it for P of 1, P of 2, etc. So 10 different arrays have to be allocated. Now, one thing you can see is that the difference in how the memory looks like in this and this, right? It's clearly there is no reason that this memory is contiguous with this. That is, this does not follow this or this does not follow this. These can be at different. Each of this chunk of 20 arrays can be at different locations, and there is no reason they have to be together nearby or anything. Okay, that's something you have to keep in mind. This is different from this. It's clear. Okay, and again, one thing is that what is statically allocated here? Here in this way, the entire 199, the 200 integers were, the memory for entire 200 integers were statically allocated. In this view, only the first 10 pointer location. So memory for storing only 10 pointer locations were statically allocated. So this array, the array of size 10, was statically allocated. All the rest of the things we had to dynamically allocate. It's clear. Now we come to the third view. Third way to do this is the following. Okay, so again, sorry, before I go, how can I access the, let's say this location, let's say this is this starts from 0 and this is 10th location, 10, index 10, exactly like we did here. We could have written, to access that I could have written, so this is 0th, right? Because this is where the 0th index points to. So I could have written this by writing, okay, this is one way I could have accessed this value. So if this is 50, so I can access values like this. This is so once you allocate the memory like this, the programmer can access that location like this, right? Now, next thing is the third view. The third view is the following view. I have declared a pointer to a pointer. Okay. So this is a pointer to an integer. So what is statically allocated? Statically, memory is allocated to store just one pointer information. This is all which is statically allocated. Okay. Now the rest of the things you have to dynamically allocate. So how do I now create a two-dimensional structure out of this? To create a two-dimensional structure, first I have to allocate this row. I have to allocate memory to store integer pointers. So that's the first thing I have to do, right? Now each of that location will then go and look, each of that location will then be looking at this bigger 20-dimensional array. Okay, so first thing I will do is I allocate to allocate this memory, we have to use malloc function. So we should write something like right. So we are saying that give me 10. So we are calling the malloc function and asking it to return a block of memory to store 10 pointer values. So that's what we do, and then we get back a void star pointer, which is then typecast into the type of PPTR of in double star. Right. So that will give me this memory. So that will give me a one-dimensional array, right? And now this one dimensional array, each point of this, each location in this one dimensional array should now be assigned, should be assigned the address of an one dimensional array. Okay, so this is of size 10. So we should now allocate an array of size 20 and using malloc and point it to, and that address should be given to each. So first we allocate one. So this is exactly like what we did here. We allocate a block of memory of size 20 integers, and then the address to that, the first address to the first location is then stored at the 0th index of PPTR. Then we again create another array and store its value in the second location, etc., just like we did here. So only difference between this and this is that here the initial array is also dynamically allocated, on the other hand here it was statically allocated. Okay, so we could have used the same, we can use the same notation here, and so like this we can now write zero zero to mean this location. Okay, so this is 0th and then 0 of that. Now 0, if you want this, let's say this is 5, then we should use here 5. Okay, on the other hand, if this was it's not the 0th but the first index which is pointing here, we should have had 1 of 5 is 10. Okay. Okay. So note that all these memory locations are not contiguous like we had it in the array. Okay. Here, this block of 10 pointers, this is contiguously allocated. Each of these blocks of 20 integers, these are also contiguously allocated, but the entire 200 integers is not contiguously allocated. Okay, that's the difference between the array notation. Okay, so we have now seen 3 ways. One is, the first way is like completely statically allocated 2-dimensional memory. Second is like partially allocated, one dimension is statically allocated, the second dimension is dynamically allocated. The third way is that all 2 dimensions are dynamically allocated. Okay, and accessing each of these points, the locations can be done using our pointer, an array like notation. Okay, thank you.